Tonight, we are going to explore something that sounds like a simple number, but quickly transforms into one of the most brutal journeys a human being could ever attempt. 1 light year. It is a phrase we toss around in science fiction as if it were a short commute. We assume the hard part is the speed, building an engine powerful enough to bridge the gap. It isn't. The hard part is the realization of what that speed brings with it. It brings forces that the human body was never built to handle and conditions that modern engineering was never designed to survive. In the deep dark, every one of these problems doesn't just persist. It gets worse the longer the journey continues. By the end of tonight, you're going to understand exactly what 1 light year actually demands, and why the distance itself is only the beginning of the problem. Before we climb aboard, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now let's begin. Start with the number. 1 light year is 5.88 trillion miles. This is the distance light travels in a single year, moving at a constant 186,000 miles per second. Nothing in nature moves faster. This speed is not a record waiting to be broken by a better engine. It is a hard boundary written into the very architecture of the universe. The cosmos set that limit at the moment of its creation, and it has held across every scale we've ever tested. So 1 light year is the distance you'd cover if you could travel at the absolute maximum speed the universe permits, sustained for an entire year without stopping. But what does that number actually represent in terms of our own home? Most people picture the solar system ending just beyond the orbit of Neptune or the icy rocks of the Kuiper Belt. But that is only the inner room of our house. Far beyond Pluto lies the Oort cloud, a vast spherical shell of trillions of icy bodies. This is the true gravitational territory of our Sun. Its inner edge begins roughly 2,000 units away, but its outer boundary stretches to 100,000 units, exactly 1 light year from the Sun. This means that the first light year of any interstellar journey is not a journey to a new world. It is the crossing of our own solar system's outermost driveway. You wouldn't arrive at a new star. You would simply arrive at the edge of the true void. Looking back from there, the Sun would no longer be a disk of fire. It would be a single, brilliant point of light, still the brightest thing in your sky, but agonizingly distant. Human intuition was never designed to feel this scale. We evolved on a planet where the fastest things moved at a few miles per hour. Nothing prepared our minds to hold interstellar distances as real quantities. So let's make it tangible. Imagine shrinking our entire solar system so that the Sun becomes a basketball sitting on a sidewalk in New York City. At this scale, the Earth is a small grain of sand sitting 85 feet away. Neptune, the outermost major planet, is a small pea sitting half a mile down the street. Voyager 1, after nearly 50 years of flight, has only traveled about 2 miles past that pea. It is still in Manhattan. Now look for the nearest star. In this model, Proxima Centauri is another basketball sitting on a sidewalk. In Honolulu, Hawaii, between those 2 basketballs, there are 4,000 miles of nothing. No gas stations, no landmarks, no emergency shelters. Just a void so thorough that it challenges the meaning of the word emptiness. This is the abyss we must cross. If you want to cover that 1 light year in a time frame a human could survive, you need speed. Start with the fastest spacecraft humanity has ever built, the Parker Solar Probe. At 430,000 miles per hour, you could circle the Earth in 55 seconds. It is the fastest object we have ever launched, and yet it is nowhere near enough. At that speed, crossing 1 light year would take over 15,000 years. The entire span of recorded human civilization fits inside that travel time, with 10,000 years still remaining. To make the journey matter, we must reach for a substantial fraction of the speed of light. At 10% of light speed, the journey takes 10 years. At 90%, it takes 13 months. These are the velocities where the physics starts getting genuinely strange. The first demand of the void is the acceleration. You cannot simply jump from rest to 10% of the speed of light in an hour. The forces involved would destroy the ship and flatten the crew. A sustained acceleration of 1g, the same pull of gravity you feel right now, is the best-case scenario. It would keep your heart conditioned and your bones solid. But even at 1g, the numbers are daunting. To reach 10% of light speed takes 35 days of continuous thrust. To reach 90% takes 730 days, 2 full years of firing the engines every single second. The problem isn't the time, it's the energy. For a hypothetical ship of 1,000 tons, firing a 1G engine for a year requires more energy than the total annual energy production of the entire Earth. We are talking about the electricity of a whole planet, for a year, just to move one ship. Physics does not offer a discount for our ambition. This is where we hit the first wall of relativity. In 1905, Albert Einstein discovered that speed affects time. This is not a metaphor, it is a measurable fact. We see it in our GPS satellites, which would be off by miles every day if we didn't correct for their relativistic drift. We see it in subatomic particles called muons, which should decay in microseconds, but survive to reach the Earth's surface only because time has slowed down for them during their high-speed journey. If you're crossing 1 light-year at relativistic speed, time dilation becomes the defining fact of your existence. This leads us to the shattered shared now. Newton believed time was a river that ran the same for everyone. Einstein showed it as a local property. If you reunite 2 clocks that were separated by high velocity, they will no longer agree. One has logged fewer seconds than the other. Scale this to a ship crossing 1 light-year at 99% of light speed, and the difference is not nanoseconds, it is weeks. For you inside the ship, the journey across 5.8 trillion miles might only take 52 days. You launch, you live through 2 months of life, and you arrive. But back on Earth, over a year has passed. Your family is older. Your world has moved on without you. You have stepped out of sync with your species. You have solved the distance of 1 light-year, but you have found that the universe keeps separate clocks for those who dare to move fast. And as you look out the window at 99% of light speed, you realize that the universe doesn't even look the same anymore. The stars are changing color, the sky is warping, and the vacuum itself is starting to glow with the light of the Big Bang. In the next section, we are going to look at the speed trap. We will explore the psychedelic tunnel of relativistic vision and discover why, at these speeds, even the empty space between stars becomes a lethal weapon. Are you ready to see what happens when the very light of the stars tries to bleach you from existence? You are no longer looking at a night sky you recognize. As your engines push you toward the light speed barrier, the very photons of the stars, the same ones that provided comfort for 4 centuries of human sailors, begin to turn into a blinding, high-energy threat. Step inside the ship. Imagine for a moment that you are standing at the forward viewport of a vessel crossing the 1 light-year mark at nearly the speed of light. It is a journey that looks nothing like the cinematic leaps of science fiction. There are no streaks of light, no tunnel of stars, and no heroic roar. In the true deep dark, the physics of velocity is much more alien, and the speed you have chosen to conquer the distance is about to rewrite your entire visual reality. This is the speed trap. In this section, we are going to explore what the universe actually looks like when you are moving at a meaningful fraction of light speed. We will discover why the stars you once knew as friends will eventually betray you, and why at these velocities, the empty vacuum between suns becomes a lethal radiation storm that no shield was ever designed to withstand. To understand the visual transformation of the journey, we must first look at the Doppler shift. You have encountered this phenomenon with sound in your daily life. When an ambulance approaches you, its siren is compressed into a higher, sharper pitch. As it passes and recedes, the sound waves are stretched and the pitch drops. Because light is also a wave, it behaves with the same mathematical cruelty. When you are moving toward a light source at relativistic speeds, the wavelengths of that light are compressed. They shift toward the blue and violet end of the spectrum. When you move away, they stretch toward the red and infrared. At 10% of the speed of light, the effect is subtle. The stars directly ahead of your ship appear slightly bluer, while the ones behind you take on a faint, reddish tint. The sky still feels familiar, but as you push toward 50% of light speed, the palette of the cosmos undergoes a radical shift. Stars that were once yellow suns now burn with a brilliant blue-white fire. Orange giants turn yellow. The forward hemisphere of your sky begins to take on a ghostly, high-energy hue. But here is the first wait. What? Moment of relativistic vision. At 90% of light speed, the Doppler shift becomes extreme. The visible light from the stars ahead is compressed so violently that it moves entirely out of your visual range and into the ultraviolet. From your perspective, the brightest stars in the galaxy effectively go dark. They disappear from your eyes, not because they are gone, but because their light has become too energetic for your biology to perceive. What replaces them are the infrared ghosts, cool, dim stars that were invisible from Earth, now shifted up into the visible spectrum by your own velocity. You are looking at a different sky, populated by stars you have never seen before. But the distortion of the universe is not just about color, it is about geometry. This is the phenomenon of relativistic aberration. Imagine you are standing in a rainstorm. If you stand perfectly still, the rain falls straight down on your head. But if you start running, the rain appears to hit you at an angle, as if it is coming from in front of you. The faster you run, the more the rain seems to crowd toward your face. Light follows the same logic. As you accelerate toward the light-year mark, the incoming starlight is bent forward by your motion. Stars that should be to your left or your right appear to shift toward the center of your path. At 90% of light speed, almost the entire visible content of the universe, every star, every galaxy, and every nebula is swept into a tight, glowing cone spanning only about 26 degrees directly ahead of you. The sky to your sides and behind you turns into an absolute, lightless black. You are flying through a dark tunnel, staring at a blazing ring of compressed starlight that surrounds a central point of nothingness. The physics of wave propagation doesn't care about your star charts. It folds the universe into a pinhole, leaving you in a sensory vacuum where the only light left in existence is the one you are running toward. But as the starlight crowds forward, a new and ancient glow begins to emerge from the darkness. This is the cosmic microwave background, the afterglow of the Big Bang itself. Normally, this radiation is completely invisible to human eyes, existing in the long wavelengths of microwaves. But at 99% of light speed, your velocity compresses this relic radiation. It blue shifts into the visible spectrum. The forward arc of your ship begins to glow with the light of the beginning of time. You are no longer looking at stars. You are looking at the fire of the early universe, made visible by the sheer violence of your own speed. You are standing at the viewport of a ship crossing 1 light-year, and you are witnessing the birth of the cosmos in a blazing ring of blue light. Now we must talk about the one thing that almost every dreamer of the stars overlooks, the interstellar medium. We have been taught that space is empty, a perfect silent void where nothing happens between point A and point B. This is one of the most dangerous deceptions in astronomy. Between the stars there is gas and dust, the remnants of suns that died billions of years ago. On average, this medium contains roughly 1 hydrogen atom per cubic centimeter. To a laboratory on Earth, this is an impossible vacuum. The best vacuum chambers we have ever built are still 100 million times denser than typical interstellar space. At the speeds humanity has achieved so far, this thinness is irrelevant. For Voyager 1, moving at 38,000 miles per hour, these atoms are ghosts that pass through the hull without a trace. But the moment you reach for 10% of the speed of light, the vacuum develops teeth. At these velocities, your ship is no longer passing through nothing. It is colliding with a landslide of matter. The hull doesn't know the difference between a fast proton hitting a stationary wall or a wall hitting a stationary proton. At 10% of light speed, every single hydrogen atom striking the bow of your ship carries a kinetic energy of approximately 400 million electron volts. This is the energy range of high-energy cosmic rays. You are flying nose first into a continuous particle beam. Think about the sandblaster effect. Every second your ship encounters trillions of atoms. Individually they deposit a tiny amount of energy, but over a journey of 1 light-year they accumulate. They heat the hull material to thousands of degrees. They create radiation damage in the molecular bonds of your ship's structure. But the real horror is the dust. Interstellar space is filled with microscopic grains of minerals and carbon. At 10% of light speed, a single grain of dust, roughly the mass of a single grain of sand, strikes your hull with the kinetic energy of over 100 kilograms of TNT. This is not an approximation for dramatic effect. It is the actual number. At 50% of light speed, it reaches 3,000 kilograms. A collision with a single mote of dust is no longer an impact. It is a detonation. At relativistic speeds, both the projectile and the hull vaporize instantly on contact, turning from solid to superheated plasma in a quadrillionth of a second. You aren't just traveling, you're being methodically dismantled by the nothingness you tried to cross. The response to this bombardment is the shielding paradox. To survive the hail of atoms and the detonation of dust, you must add mass. You imagine a massive, sacrificial shield, meters of water or polyethylene, at the leading edge of your ship. Water is an excellent choice because hydrogen nuclei absorb particle energy without generating the same secondary showers of radiation that metals do. But meters of water represent an enormous amount of mass. And as we learned in Section 1, mass is the thing the energy equations tax without mercy. Every kilogram of shielding you add requires more fuel to accelerate, which requires more fuel to move that fuel, leading to a spiral of exponential cost that dwarfs the annual energy production of our entire planet. You are trapped in a closed loop. You need the speed to survive the time, but the speed turns the space into a weapon, and the armor you need to survive that weapon makes the speed impossible to achieve. The speed trap has won, not by stopping your engines, but by turning the universe into a solid wall. You have built a ship that can cross 5.8 trillion miles, but you have found that the faster you go, the more the galaxy tries to bleach your DNA and vaporize your hull. You have survived the driveway paradox of the distance, but you are losing the battle of the particle beam. And yet, while you struggle with the blue shifting stars and the exploding dust, you are ignoring the most silent assassin of all. We think that if we can just solve the shielding, if we can just build a better radiator and a thicker plate, we will arrive. But the human body is not a machine. It is a biological history, and while the ship tires, the body itself is beginning to undergo a systematic dismantling that no exercise or medicine can stop. We think that if we can just survive the crossing, the destination will save us. But as we are about to discover, the lack of gravity and the presence of these very radiation storms we just described are performing a much more visceral surgery on the traveler's life. In the next section, we are going to look at the biological cost. We will explore the skeletal wash and the spherical heart, and why the first person to travel 1 light-year might arrive as a frail, blind ghost of the human who left Earth. Are you ready to see why on an interstellar voyage, your own skeleton is the first thing that will betray you? On Earth, gravity is the invisible architect of our existence. From the first moment of your conception to the last breath you take, the constant 1G pull of our planet has acted as a master sculptor, defining the density of your bones, the strength of your heart, and the very shape of your cells. We walk through our lives unaware of this force, never realizing that every step we take is a rhythmic dialogue between our biology and the Earth. We have spent 4 billion years evolving in this heavy cradle, and every system in our body, from the way our blood circulates to the way our muscles respond to constant mechanical stress, is a response to that specific gravitational pressure. But interstellar space breaks this dialogue. In the deep dark, that architectural hand is withdrawn, and the human organism begins to dismantle itself. This is the biological barrier. In this section, we are going to explore why the human body is not a universal traveler, but a planetary response, and why the most lethal enemy in the deep dark is the very biology that allows you to breathe. To understand the scale of this dissolution, we must first look at the most vital engine in your body, the heart. On Earth, your heart is a powerful muscular pump that has spent your entire life fighting the vertical pull of gravity to push blood upward to your brain. It is an engine designed for a high-resistance environment, but inside the hull of your starship, that resistance evaporates. In the weightlessness of the between, your heart suddenly finds its work to be catastrophically easy. With gravity no longer pulling blood toward the lower body, the cardiovascular system is forced to operate under completely different conditions. Your heart, sensing that its full power is no longer required, begins to atrophy. It does not just weaken, it physically changes its shape. Data from long-duration missions show that the human heart becomes more spherical in space, losing its elongated efficiency as the muscle mass shrinks. You are living with a heart that is slowly forgetting how to be a pump, becoming a smaller, weaker engine that no longer remembers the demands of its home world. But while the heart shrinks, your internal fluids begin a chaotic and unsettling migration. On Earth, gravity pulls your blood and interstitial fluids toward your feet. On a starship, that pull is gone. The result is the fluid shift. Within days, the liquids in your body move upward, flooding your chest and your skull. Your legs become thinner, a phenomenon sometimes called bird legs, while your face can become swollen and puffy. But this is not merely a cosmetic shift. The increased pressure inside your skull begins to push against the back of your eyes, flattening the eyeballs and inflaming the optic nerves. This is the first what? Moment of the biological barrier. You did not go to the stars to go blind, but the lack of weight is physically crushing your vision from the inside out. This condition, known as spaceflight-associated neuroocular syndrome, means your eyes, the very tools you need to navigate the void, are being systematically deformed by the absence of the Earth's pull. While your vision blurs and your heart shrinks, your skeletal system begins a much more permanent retreat. On Earth, your bones are not static rocks, they are dynamic mineral banks. Your body constantly deposits calcium into your bones to keep them strong enough to support your weight, and it withdraws calcium when it needs it elsewhere. But in the deep dark, your skeleton receives a terrifying message: you are no longer needed. Because you are weightless, your body realizes that your bones are overbuilt for the environment. In long-duration microgravity, the body enters a form of accelerated bone loss unlike anything experienced by a healthy person on Earth. Without effective countermeasures, you can lose roughly 1% or more of your bone mineral density per month in your most vulnerable weight-bearing bones, the spine, the hips, and the legs. This leads to the skeletal wash, the most visceral evidence of our biological fragility. The calcium released from your bones enters the bloodstream, and some of that excess is eventually excreted through your urine. In a very literal sense, part of the skeleton you are losing is leaving your body through the ship's recycling system. You aren't just living in space, you're losing the physical materials that make you a creature of Earth. Within a few years, your bones could become so porous and brittle that they resemble glass. You are becoming a ghost in a machine, a fragile shadow of the human who once stood on the launch pad. The biological siege is compounded by the information decay of the human cell. We talked about the radiation barrier in the previous section, but here we must look at the biological receipt. Even if your ship has advanced shielding, galactic cosmic rays, those heavy ionized nuclei moving at relativistic speeds, will find their way into your tissue. When one of these particles strikes a human cell, it can shatter the double helix of your DNA. Your body has evolved mechanisms to repair this damage, but those mechanisms were built for the environment of Earth. In the deep dark, the hits come too fast and too hard. Your DNA becomes a mosaic of errors, a corrupted file that may cause long-term neurological and biological damage. Your immune system, already weakened by the stress of isolation, begins to fail. You don't just risk cancer, you risk a total systemic breakdown of the biological code that defines your species. This creates the ultimate evolutionary trap. We imagine ourselves as interplanetary travelers, moving back and forth between the stars and the Earth. But biology is a one-way door. After years of microgravity, returning suddenly to Earth's gravity could become a medical crisis. A weakened cardiovascular system, fragile bones, and a heart that has changed shape would struggle to survive the return of the vertical. The sudden return of Earth's pull would feel like a crushing weight on your chest, potentially making simply standing an enormous physiological challenge. You have survived the journey, but you have lost the physical right to walk on the world that birthed you. You have become a biological exile. This leads to the most unsettling question of the biological barrier, the question of the generations. If a single human life is dismantled by the void in decades, what happens to a civilization that attempts to stay for lifetimes? If humans were to reproduce for generations in an environment radically different from Earth, the long-term consequences are almost impossible to predict. Over enough generations, natural selection and environmental pressures could potentially push such a population in a different evolutionary direction. We may be witnessing the first steps towards something that resembles a separate branch of humanity, a species of the dark that is physically and genetically incompatible with the rest of our family. We didn't go to the stars to expand humanity, we went there to watch it divide. The biological barrier reveals the final irony of our ambition. We have spent billions of dollars trying to solve the problems of engines and fuel. We have built ships that can bend space and reactors that can power cities. But we have forgotten that the most complex and fragile machine on the ship is the one we didn't build, ourselves. The human body is not a universal constant, it is a planetary response. It is a piece of the Earth that has been temporarily granted consciousness. When we try to remove it from the Earth begins to pull its atoms back. We aren't conquering the universe is digesting us, one bone and one cell at a time. The hero of the starship is a myth. The reality is a frail, elongated survivor who has traded their heritage for a heartbeat. We have survived the distance barrier, the speed barrier, and the radiation barrier. We have even endured the time barrier that turned our families into ghosts. But now we have hit the wall of our own skin. We have realized that the machine is stronger than the pilot, and this leads us to the next, most logical link in the chain. If the human body is too fragile for the journey, if we are being dismantled by the very vacuum we are trying to cross, then the mission must rely on something more durable. It must rely on the self-sustaining machine. But as we are about to discover, the machine has its own expiration date. In the next section, we are going to look at the self-sustaining barrier. We will explore why a starship is not a vehicle at all, but a fragile island of order drifting through an ocean of entropy. Are you ready to see why the greatest threat to a 100-year voyage isn't a lack of fuel? It's the fact that machines, like men, eventually lose their will to function. Every breath you have ever taken was a gift you didn't have to earn. On Earth, we live in a state of biological grace. You don't wake up in the morning and check the status of the atmosphere. You don't worry if the wind has forgot how to carry oxygen or if the trees have gone on strike. We are the spoiled children of a generous mother, never realizing that the very air in our lungs is a product of a vast, complex, and unmanaged planetary harmony. But as your ship crosses the 1 light-year mark, that grace is withdrawn. On an interstellar voyage, breathing is no longer a biological right, it is an industrial output. This is the self-sustaining barrier. In this section, we are going to explore why a starship is not a vehicle at all, but a fragile island of order drifting through an ocean of entropy. We will see why the greatest threat to a 100-year voyage isn't a lack of fuel, but the terrifying reality that in total isolation, both machines and civilizations eventually lose the will to function. To understand the horror of the machine, we must first look at the parasitic outpost. On Earth, we celebrate the International Space Station as a triumph of human persistence. But the station is not a starship, it is a parasite. It is tethered to Earth by a continuous, invisible umbilical cord of resupply. Every few months, a vessel arrives carrying fresh water, new oxygen canisters, and spare electronics. Behind the crew stands a literal army of thousands of engineers on the ground, monitoring every breath of the station in real time. Without that continuous support from Earth, the station's long-term survival would eventually become impossible. An interstellar mission has no mother world to call upon. The moment the engines fire, the umbilical cord is not just stretched, it is severed. You are no longer an explorer. You are a resident of a high-tech CPR machine, and every year the rhythm becomes harder to maintain. This leads to the first what moment of the self-sustaining barrier, the realization that total closure is a physical impossibility for human engineering. Every space mission in our history has depended on an open-loop system. We take what we need from Earth and discard what we don't. But on a century-long journey, every critical resource you carry at launch is the total inventory you will ever have. You must achieve a perfect 100% closed loop. In the late 1980s, humanity attempted to model this with Biosphere 2. It was a 3-acre sealed ecosystem designed to support 8 people indefinitely. But within 2 years, its oxygen levels had fallen dramatically, its ecology had become unstable, and the experiment had exposed a humbling truth. We can build machines that scrub air and filter water, but we cannot replicate the billions of years of evolutionary tuning that keep a planet in equilibrium. A starship's life support is not a garden. It is a clinical resuscitation of a dying world. Even if the ecosystem remains stable, the mechanical entropy of the ship will eventually claim the mission. On Earth, we believe that strong means permanent, but in the reality of the deep dark, time is a solvent. Every moving part has a finite operational life. Bearings wear out, seals age, and electronic components suffer from electromigration, where electricity physically pushes atoms out of place, creating microscopic voids. Over a 100-year voyage, your ship will experience millions of thermal cycles, creating material fatigue that grows with every year of flight. The terrifying reality is not that a single processor might fail, but that the ship's very capability to replace it might go extinct. To keep a starship functional for a century, you don't just need spare parts. You need an entire industrial civilization capable of manufacturing them from scratch. You are in a race against the slow, quiet disintegration of your own world, and the universe is methodically dismantling the finish line. But as the metal tires, a much more profound decay begins to take hold inside the mind of the colony, the knowledge divorce. A starship is not just a collection of wires, it is a collection of ideas. The systems that keep you alive, the reactors, the scrubbers, the navigation computers, are the products of thousands of years of accumulated human expertise. But knowledge is a living thing. It requires a culture to survive. History shows us that specialized knowledge can vanish in a single generation if the social structures supporting it are disrupted. After the fall of the Western Roman Empire, Europe forgot how to make concrete for 1,000 years. The aqueducts were still standing, the structures were still visible, but the people living in their shadow no longer knew the recipe to fix them. They had lost the language of their own technology. Imagine your ship in year 80 of its journey. The people currently in charge were born in the void. They have never seen an ocean or a factory. They have learned their engineering from manuals written by ancestors who have been dead for decades. If a master engineer dies before their apprentice is fully trained, a tiny sliver of the ship's survival is lost. Over a century, these microlosses accumulate into a dark age of engineering. The crew might still know how to operate the ship, but they may no longer understand the fundamental physics required to innovate when an unexpected failure occurs. They become ritual technicians, performing the motions of maintenance without the depth of understanding. They are the residents of a high-tech haunted house, surrounded by machinery they can no longer truly control, praying that the machine mother doesn't stop breathing. The psychological toll of this isolation creates a state of cultural stagnation. On Earth, we are part of a global conversation, constantly renewed by new ideas and unpredictable challenges. But on a starship, the library is finite. The conversations have all been had. When every resource is rationed and every role is predetermined by the ship's survival needs, the drive for creativity dies. You are building a society where change is a threat to the equilibrium. You have reached for the stars, but you have done so by turning humanity into a maintenance unit for a machine that has forgotten why it left home. The greatest distance on an interstellar voyage isn't the light years between suns. It is the gap between the people who launched the ship and the people who must finish the journey. This leads to the final, most haunting irony of the self-sustaining barrier, the arrival. We imagine that once the ship reaches another star, the struggle ends. But as we saw in the previous sections, reaching the destination is only half the problem. If you arrive at a world that is not a second Earth, a world like Proxima b, you are faced with an impossible choice. You cannot land because your body has been dismantled by the journey. You cannot return because your fuel is gone. Your only option is to continue living in the machine. But the machine is now a century old. Its electronics are degrading, and the deep knowledge of its construction is a fading memory. The self-sustaining machine was never meant to be a permanent home. It was meant to be a bridge. And when the bridge doesn't lead to a shore, it becomes a cage. The self-sustaining barrier has won, not by a sudden explosion, but by the slow, relentless pressure of entropy. You have built a ship that can survive the radiation and the vacuum, but you have found that you cannot build a civilization that can survive time. You have traded the messy, dangerous, but self-healing world of Earth for a sterile, perfect, but terminal island. We are the first generation to realize that the most dangerous thing about interstellar travel isn't the distance. It's the fact that the universe does not provide a save point. Once you leave the cradle, you are in a race against the decay of your own technology and the narrowing of your own mind. But even as we huddle in our aging tunnels, watching the machines tire and the memories fade, we are still facing the final, absolute ceiling of our reality. We think that if we can just solve the maintenance, if we can just perfect the closed loop, we will eventually claim the galaxy. But the stars themselves have set a limit that no amount of endurance can bypass. A limit that ensures that no matter how fast we go or how long we last, the universe will always be bigger than our reach. In the next section, we are going to look at the physics barrier. We will explore the speed of light wall and the horizon of causality, and why the universe itself may be structured to ensure that no two civilizations can ever truly share a single now. Are you ready to see why the final wall isn't an engineering problem, but a law of nature? There is a wall in the universe that no engine can burn through, no shield can absorb, and no civilization can negotiate with. It does not care how advanced we become. It does not care how much energy we possess. It does not even care whether we understand its nature. It is built into the most fundamental relationship between space, time, and causality itself. This is the physics barrier. Throughout this journey, we have seen how every solution has simply opened the door to a more terrifying problem. Faster engines created energy crises. Relativistic speeds created radiation storms. Long-duration journeys created biological collapse, and closed systems created mechanical and institutional decay. But beneath all of these technological hurdles, we have finally reached a threshold that cannot be out-engineered. We are about to discover that the universe may not be a connected whole, but a collection of isolated islands, partitioned by a logic that ensures every civilization remains a prisoner of its own coordinates. To understand the absolute finality of this wall, we must first look at the speed of light, not as a target, but as a boundary of logic. In our popular culture, we treat the number c, 300,000 kilometers per second, as a speed limit, much like those on our highways. We imagine it is a record waiting to be broken by a sufficiently powerful machine. But in the language of physics, the speed of light is the speed of causality. It is the maximum rate at which one event in the cosmos can influence another. This is the first what moment of the final barriers. The speed of light is not a limitation of our current technology. It is the refresh rate of reality itself. The universe has a built-in delay, a latency that is hard-coded into the vacuum, ensuring that no piece of information can ever outrun the fabric that carries it. Most people understand the energy debt of approaching light speed, the fact that as you go faster, the energy required to accelerate further rises without bound. But the physics barrier reveals a much more disturbing reason why this limit is impenetrable. It isn't just about the power of your reactor. It is about the consistency of time. In the framework of special relativity, faster-than-light signaling would allow some observers to describe a signal as arriving before it was sent, effectively opening the door to violations of causality. If you can move information faster than light, you are no longer just moving through space. You are potentially moving out of the logical sequence of history. You are creating a universe where an effect could precede its own cause. This leads us to the chronology protection conjecture, a concept famously proposed by Stephen Hawking. It suggests that some unknown physical mechanism, perhaps a runaway quantum feedback loop in the vacuum itself, may prevent closed time-like curves from ever becoming physically realizable. The universe appears to protect its own timeline with a ferocity we are only beginning to comprehend. We aren't just looking for a faster engine. We are attempting to commit a logical crime against the structure of reality. And the evidence suggests that the laws of physics act as a cosmic immune system, shutting down any attempt to bypass the fundamental order of time. Think about the light cone, the geometric representation of everything that can ever influence your existence. Every star you can see, and every event you can experience sits within this bubble. Beyond it lies the elsewhere, regions of the universe that are physically, causally, and permanently disconnected from you. For practical civilization-scale travel, the reachable universe may be only a tiny fraction of the observable universe. We are witnessing a partitioned cosmos, a reality that has been broken into isolated cells. You are not a citizen of the galaxy. You are a resident of a light cone, and the laws of physics have ensured that you can never step outside its walls. This isolation is compounded by the terrifying reality of cosmic expansion. We live in a universe driven by the mysterious pressure of dark energy. This means that every second, the distance between us and the furthest galaxies is growing. But here is the realization that dwarfs our ambition. Because cosmic expansion is accelerating, some sufficiently distant regions are already receding from us so rapidly that light emitted there today will never reach Earth. They have already slipped over the cosmic event horizon. Every day, stars that were once part of our future are crossing this line and vanishing from our future forever. We are living in a house where the rooms are moving away from each other so fast that we can only ever stay in the hallway. The universe is not a frontier for us to claim. It is a fading miracle that we are only allowed to watch as it retreats into the dark. The psychological toll of the physics barrier is a state of civilizational humility. On Earth, we have always believed that we could conquer any distance, but the laws of nature tell a different story. They suggest that an interstellar empire is a contradiction in terms. If it takes years for a message to travel between suns, there is no shared now. There is no accountability. There is no collective intelligence. A species that spreads across the light years is a species that fragments into isolated, diverging pieces that eventually forget their common origin. The universe has set a causal lockdown on intelligence, ensuring that every civilization develops and dies in absolute clinical isolation. This provides the deepest possible connection to the Fermi paradox. We point our radio telescopes at the sky and wonder why the silence is so absolute. Perhaps it isn't because life is rare, or because civilizations are short-lived. Perhaps it is because every advanced intelligence eventually reaches the same mathematical conclusion. The door is locked. They look at the speed of light wall and the horizon of causality, and they realize that the resources required to fight the universe's own logic are better spent elsewhere. The silence of the stars might be the sound of a billion civilizations deciding that out was never an option. We are looking for neighbors in a universe where the laws of nature act as the ultimate social distancing protocol. But there is a final, most unsettling irony buried in the physics barrier. We often talk about the dream of the stars as if it were a future event. But physics tells us that the stars we see are not there. Because of the light delay, we are looking into a graveyard. Some of the brightest suns in the night sky may have already exploded or faded, but their ghosts are still traveling toward us. We are obsessed with reaching a reality that has already passed us by. We are like children chasing the image of a ship that sailed centuries ago, never realizing that the ship is already dust. The physics barrier has ensured that we can never truly arrive, because by the time we do, the destination we aimed for has already ceased to exist. One by one, every solution has opened a deeper problem. We solved the distance with speed, and speed gave us the energy wall. We solved the energy with the dream of warp drive, and warp drive gave us the horizon trap. We solved the journey with self-sustaining machines, and the machines gave us mechanical decay. And now, beneath all of them, we have reached the fundamental structure of the cosmos, a structure that refuses to hold still and refuses to let us through. The physics barrier is the final verdict of the universe, a reminder that we are not the masters of space-time, but its products. We are a planetary event, and the universe has ensured that we remain one. But as the realization of our isolation sets in, as we look up at the stars and see the walls of our cage, a new and much more profound question remains. If the barriers of physics are absolute, and the stars are logically unreachable, then what was the purpose of the dream? Why did we spend centuries building the telescopes and the equations for a road that doesn't exist? What happens to a civilization when it finally accepts its own insignificance? In the next section, we are going to look at the civilization barrier. We will move from the laws of the universe to the laws of the species. We will ask if a civilization can even survive long enough to build the ships, or whether the chain of barriers is designed to outlast every species that dreams of escaping its home world. Are you ready to see why the greatest threat to reaching the stars might be the very people who want to go? The most fragile part of a starship is not the nuclear reactor, the navigation computer, or even the reinforced hull. It is the internal stability of the civilization that wants to go. Throughout our history, we have treated the universe as a physical obstacle course, assuming that if we can just solve the energy and the shielding, the galaxy will be ours. But we have forgotten the most fundamental mismatch in our nature. We are a species that thinks in seasons, attempting to master a journey that outlasts empires. This is the civilization barrier. We are about to discover why the greatest threat to reaching another sun is not the distance or the energy of a pulsar. It is the fact that human society was never designed to honor a single purpose for 1,000 years. We are launching a ship into a future where the world that sent it no longer exists. To understand the weight of this barrier, we must look at the mismatch of timelines. On Earth, we build for the next election, the next quarterly report, or at most, the next decade. Our longest-standing institutions, our governments, our religions, and our corporations rarely survive more than a few centuries without undergoing radical, often violent transformations. But an interstellar journey is a project that operates on a geological timescale. Even with the most advanced propulsion we can realistically conceive, a mission to a distant star system is a commitment of multiple centuries. Humanity has rarely maintained a single institutional purpose unchanged across anything approaching that timescale. If you launch a ship today, you're betting that the civilization on Earth will still be coherent enough to listen for your signal 4 centuries from now. You are betting that the funding won't be cut, the mission won't be forgotten, and the technology to receive your data won't be lost in a period of historical regression. Think about the maintenance of purpose. On Earth, if we build a bridge or a dam, it is part of a living economy. Its value is immediate and visible. A starship, however, is a silent investment. Once it leaves our solar system, it provides no economic return for generations. It is a massive drain on planetary resources that offers only the abstract promise of data in the distant future. In a world of shifting priorities and resource scarcity, how long does the dream stay protected? Within 3 generations, the people on Earth will have no personal connection to the crew. The pioneers will not be fathers or sisters. They will be names in an ancient digital archive. The temptation to switch off the giant radio dishes and redirect those resources toward local crises will eventually become overwhelming. We are an impulsive species, and the stars demand a level of collective patience that we have never demonstrated in our history. This leads to the risk of technological erasure. We imagine that progress is a straight line, always moving toward greater complexity. But history shows us that technological progress is not guaranteed to move in a constant direction. Civilizations reach peaks of achievement and then undergo periods where the knowledge required to sustain their infrastructure is lost. We see the shadows of this in our own past. After the fall of the Western Roman Empire, the specific engineering knowledge required to fix the aqueducts drifted away. The structures were still standing, but the recipe for their maintenance had vanished. On a civilizational scale, this risk is magnified for interstellar travel. If the home world experiences a great reset, a breakdown of the global supply chain, or a period of prolonged instability, the infrastructure required to maintain contact with a starship would be the first thing to vanish. The ship, hurtling through the dark, would continue to transmit its findings into a void where no one is left to hear. The starship becomes a floating fossil, carrying the high-tech dreams of a dead era into a future that has forgotten its name. But the barrier is not just about the people on Earth. It is about the micro-society inside the ship. As we have seen, a starship must become its own self-sustaining world. But a population of a few thousand people, isolated in a pressurized environment for centuries, is a sociological experiment with no precedent. On Earth, our societies stay stable because they are open systems. We are constantly renewed by the diversity of a whole planet. But the ship is a closed system. Every social friction, every ideological shift, and every political disagreement is magnified by the absolute confinement of the hull. Imagine a generation born in year 80 of the voyage. They did not choose this mission. They were born into a metal cylinder because of a decision made by ancestors they never met. This forces the ship toward an absolute, technocratic autocracy where dissent is a terminal threat to the air supply. By the time the ship reaches the destination, the people inside may have abandoned the very science and morality they were sent to preserve. This brings us to a concept that haunts the search for extraterrestrial intelligence, the Great Filter. The silence of the galaxy suggests a barrier that almost no civilization manages to cross. Perhaps the Great Filter is not a law of physics at all, but a recurring failure of complexity itself. It suggests that the energy and resources required to become a multistellar species are so enormous that any civilization capable of building a starship is also capable of destroying itself. To reach for the stars, a species must possess the power of a god, but they often retain the instincts of a survivalist ape. The civilization barrier implies that the window of opportunity for interstellar travel is incredibly narrow. A species must be advanced enough to do the mathematics, but stable enough to avoid the fire. We are looking for neighbors in a universe that is a graveyard of civilizations that ran out of time. Think about the psychology of the backup. We tell ourselves that we must go to the stars to save humanity, to ensure that if Earth falls, a colony on another star will keep the light alive. But a colony that is 10 light years away is not a backup. It is an entirely separate, isolated event. If Earth falls, the colony cannot be resupplied or rescued. The effort required to create that fragment could be vastly greater than the effort required to preserve and fix the world we already have. The interstellar dream often acts as a civilizational distraction, a mirage that lures us into spending our limited focus on a road to nowhere, while the cradle we were meant to tend is neglected. The civilization barrier does not make interstellar travel physically impossible, but it makes it historically and socially fragile. It shows us that the stars are not our future, they are our mirror. The civilization barrier reveals that we are a species that is allergic to the long term. We are evolved for the sprint of the next season, not the marathon of the next millennium. We look at the stars and see a destination, but we should be looking at them as a reminder of our own fragmentation. They show us that we are a collection of tribes struggling to become a unified species. Our curiosity is a flame that requires a level of stability we have not yet mastered. We have survived the first 6 rungs of the ladder, but we have done so by realizing that the links in the chain are not just made of physics, they are made of us. But if the physics is absolute and the biology is fragile and the civilization is unstable, then why do we still feel the pull? Why did the universe give us the ability to see the stars and the intelligence to calculate their distance if the door was always meant to stay closed? There is one final layer to this mystery, one that reaches beyond the engines and the politics and into the very fabric of our perception. In the next section, we are going to look at the physics of isolation. We will explore why the universe might be structured to keep us apart, and why the greatest gift of the stars was not the destination, but the clarity they give us about the home we have right here. Are you ready for the final, heartbreaking realization of the human odyssey? We have looked at why we can't go. Now, we must ask why we were ever allowed to dream of it. We have spent this journey climbing a ladder of increasingly brutal realities. We have seen how the vacuum destroys the machine, how the radiation shatters the cell, and how the time lag severs the soul. We have analyzed the barriers as if they were technical problems to be solved by some future genius, an engineering hurdle that can be bypassed with enough energy or persistence. But as we reach the seventh rung of this ladder, we must confront a truth that is far more profound and unsettling than any engineering failure. We must ask a question that reaches into the very fabric of why anything exists at all. Why can we see the stars if the universe has made it impossible to reach them? Why did nature grant us the intelligence to calculate the distance to the nearest sun, only to ensure that the crossing would require the sacrifice of our own humanity? This is the physics of isolation. We are about to discover that the chain of barriers is not a series of accidents. It is a fundamental property of the cosmos. We will see why the universe is not a shared home, but a collection of isolated causal cells, and why the most absolute wall in the universe is not made of distance, but of the very logic of information. To understand the physics of isolation, we must first confront the lying light. When you stand outside on a clear night and look up at the stars, your eyes tell you that you are looking at a single, unified moment in time. You see a tapestry of light and assume that everything in that tapestry is there. But this is the first and greatest deception of the universe. Because of the finite speed of light, you are not looking at the universe as it is. You are looking at a historical archive. The light from the nearest star left 4 years ago. The light from the center of the galaxy left 26,000 years ago. The light from distant galaxies has been traveling for billions of years. This means that the night sky is a hall of mirrors where every object exists in a different version of the past. You are trying to find your place in a reality that has no shared now. This is the first major realization of isolation. The universe has a built-in delay that ensures every observer is perpetually out of sync with the rest of existence. We are shouting at ghosts, and we are being guided by signals from a graveyard. This leads us to the most restrictive geometry in all of physics, the light cone. Imagine the history of your life as a single point in space and time. From that point, a cone of light expands outward into the future. This cone represents every part of the universe that you can ever influence, and every part that can ever influence you. Anything that sits outside this cone is physically, causally, and permanently irrelevant to your existence. We call this region elsewhere. In our everyday lives, our light cones are so large compared to our movements that we feel connected to the whole world. But at the scale of the stars, the light cone becomes a prison cell. The physics of isolation suggests that we are trapped inside a bubble of causality that is tiny compared to the vastness of the galaxy. We can see the elsewhere through our telescopes, but the laws of physics ensure that we can never touch it. We are like prisoners in a room with a single high window. We can see the horizon, but we are mathematically forbidden from ever walking toward it. Think about the speed of logic. Most people focus on the speed of light as a travel limit, a number on a speedometer, but the real barrier is that light speed is the maximum rate at which the universe knows itself. If a star on the other side of the galaxy explodes today, the Earth will not know about it for 26,000 years. For all intents and purposes, until that light arrives, the event has not happened in our universe. This is the causal lockdown. The universe is not a synchronized machine. It is a collection of fragments that are constantly trying to catch up to one another. The barrier we can't escape is the realization that to cross the stars is to attempt to outrun the very logic that allows cause and effect to function. If you could travel faster than light, you wouldn't just be moving fast. You would be violating the fundamental order of time. The universe prevents this not because it is cruel, but because it must remain logically consistent. Isolation is the price we pay for a universe that makes sense. This brings us to the most chilling dimension of our isolation, the cosmic event horizon. We live in an expanding universe, driven by the mysterious pressure of dark energy. This means that every second, the distance between us and the furthest galaxies is growing. But here is the realization that dwarfs our ambition. Because cosmic expansion is accelerating, there are regions of space that are already receding from us so rapidly that light emitted there today will never reach Earth. They have already slipped over the cosmic event horizon. Every day, stars that were once part of our future are crossing this line and vanishing from our possible reality forever. We are living in a universe that is actively erasing itself, methodically deleting the very possibilities we dream of exploring. The physics of isolation tells us that the observable universe is a shrinking island of light in an ever-widening ocean of nothingness. We aren't just limited by our technology, we are being outrun by the fabric of reality itself. The psychological toll of this realization is the death of the interstellar dream. For centuries, we believed that the galaxy was a frontier, a place where we could spread our seeds and build a unified human empire. But the physics of isolation proves that such a structure is a physical impossibility. An empire requires a shared timeline. It requires the ability to govern, to communicate, and to respond. But as we saw in the communication wall, if a message to a colony takes a decade to arrive, and a reply takes another decade, there is no shared now. There is no accountability. There is no collective identity. Each colony becomes its own separate event, drifting further away from its origin in language, culture, and biology. The universe has placed a security protocol on expansion, ensuring that no species can ever become a single, connected entity across the light years. We are doomed to remain planetary, not because we are weak, but because the universe is partitioned into silos of silence. This provides the deepest possible answer to the Fermi paradox. We look at the silence of the stars and wonder why no one has called us. Perhaps it isn't because life is rare, or because civilizations are short-lived. Perhaps it is because every advanced intelligence in the history of the galaxy eventually reaches the same mathematical conclusion: the door is locked. They do the math on the light cone, they measure the expansion of the abyss, and they realize that the energy required to fight the universe's own structure is a waste of a civilization's potential. The silence of the stars might be the sound of a billion civilizations realizing that home is the only thing that actually exists. We are looking for neighbors in a universe where the laws of nature act as the ultimate social distancing protocol. We aren't hearing from the aliens because they have accepted their isolation, while we are still shouting at a wall we haven't realized is there. Think about the illusion of vision. Why did the universe give us the ability to see the galaxies if we can never reach them? Perhaps the answer is not a promise, but a mirror. The stars exist at these impossible distances to show us the value of the one place that actually works. The bigness of the universe is the context that defines our rarity. If the stars were easy to reach, they would have no value. Their distance is what makes them sacred. By making the crossing impossible, the universe forces us to look back at the Earth. It tells us that we are a localized miracle, a flicker of warmth in a cold and partitioned abyss. The barrier is not an obstacle to be overcome. It is a boundary that defines our home. We are the infants who want to leave the backyard, but the backyard is the only place in the universe where we can breathe. Our sight allows us to witness the grandeur of the machine, but our physics ensures we remain observers rather than masters. The physics of isolation reveals the true tragedy of the pioneer. We have used archetypes like Elias Thorne to imagine the first human to cross the void. But as we have seen, the more Thorne succeeded in his journey, the more he was erased from our world. He moved out of our light cone, out of our time stream, and eventually out of our species. He is the evidence that you cannot go to the stars without becoming a stranger to the Earth. He is a ghost from an elsewhere that we can see but never understand. The return of the pioneer is not a triumph. It is a collision between two different causalities. He has returned to find that the home he aimed for is no longer in his timeline. He is the victim of a universe that does not negotiate its rules for the sake of our curiosity. As we look at the chain of barriers, the fuel, the pressure, the radiation, the time, and the logic, we realize that they all lead to this one final point. The universe is not a playground, it is a system of sovereign cells. Each star is a cell, and each civilization is a momentary pulse of energy inside that cell. We have spent 2 hours looking for the key to the cage, only to find that the cage is the universe itself. We are the products of the very laws that keep us apart. And yet, while the physics of isolation tells us we are alone, it also tells us we are present. We are here, we are now, and in a universe where now is a rare and fragile thing, that presence is the only achievement that matters. The barrier is not there to stop us, it is there to define us. Physics of isolation has won, not by breaking our spirit, but by defining our reality. We have survived the climb, but we have reached a peak where the air is too thin to breathe and the sky is too dark to map. We have realized that the stars are not destinations, they are the boundaries of our prison. And as we look at the chain of barriers one last time, we realize that the final link is the realization that we were never meant to leave. One by one, every solution has opened a deeper problem. We solved the distance with speed, and speed gave us the energy wall. We solved the energy with the dream of warp drive, and warp drive gave us the horizon trap. We solved the journey with self-sustaining machines, and the machines gave us mechanical decay. And now we have reached the fundamental structure of the cosmos, a structure that refuses to let us through. But even as the door closes, even as we accept the silence of the void, one final realization remains. If we are trapped on this island and the ocean is too big to cross, then how should we live? What happens to a species that finally accepts its own limitations? In our final section, we are going to look at the final verdict. We will explore the philosophy of the speck and the true reason why humanity's future is not in the stars, but with the Earth. We will discover that the greatest victory of our species was not building the starship, but understanding why we didn't need to. Are you ready for the final, heartbreaking realization of the human odyssey? The ladder is finished. Now we must look down. We have spent this journey obsessing over the machines we build, the fuel we burn, and the geometry of the space we fold. We have treated the starship as the hero of the story, a steel fortress designed to protect us from the vacuum. But we have ignored the most complex, the most fragile, and the most stubborn piece of hardware in the entire mission, the one we didn't build, the human body. To the universe, you are not a pioneer, you are a planetary fossil. You are a biological system written, line by line, over 4 billion years to function in one specific pressure, under one specific radiation count, and within one specific gravitational pull. The moment you leave the Earth, you are running a piece of ancient, terrestrial software on a cosmic hardware that was never meant to support it. This is the biological barrier. In this section, we are going to explore why your own DNA is the ultimate limit of interstellar travel, and why the very biology that keeps you alive on Earth becomes the instrument of your destruction in the dark. To understand the scale of the breakdown, we must first look at the signal of weight. Most of us think of gravity as a burden, a force that makes our backs ache and our steps heavy. But to your cells, gravity is a nutrient. It is a constant, rhythmic signal that tells your heart how to pump, your bones how to grow, and your eyes how to focus. In the weightlessness of the between, that signal is cut. This is the first what moment of the biological wall. Your body doesn't just relax in zero-G, it begins to systematically deconstruct itself. It assumes that because the weight is gone, the infrastructure of an Earthling is now an unnecessary expense. Your body starts to delete the parts of you that make you human. The first system to react is the heart. On Earth, your heart is a high-pressure engine, a muscular masterpiece that spends every second of your life fighting the vertical pull of gravity to push blood upward to your brain. It is an engine built for a high-resistance world, but inside the hull of a starship, that resistance vanishes. Your heart suddenly finds its work to be catastrophically easy. Sensing that its full power is no longer required, the heart muscle begins to atrophy. It does not just weaken, it physically changes its shape. Data from long-duration space missions show that the heart becomes more spherical in the void, losing the elongated, muscular efficiency it needs to function on a planet. You are living with a heart that is slowly forgetting how to be a pump, becoming a smaller, weaker bag of fluid that no longer remembers the demands of its home world. But while the heart shrinks, your internal fluids begin a chaotic and unsettling migration. On Earth, gravity pulls your blood and your lymph toward your feet. On a starship, that pull is gone. The result is the fluid shift. Within days, the liquids in your body move upward, flooding your chest and your skull. This is the reason for the bird leg phenomenon seen in astronauts, where the lower body withers while the face becomes permanently swollen and puffy. But the real horror is what happens inside the bone vault of your head. The increased pressure of cerebral fluid begins to push against the back of your eyes, flattening the eyeballs and inflaming the optic nerves. This is the nightmare of SANS, spaceflight-associated neuroocular syndrome. You did not go to the stars to go blind, but the lack of weight is physically crushing your vision from the inside out. Your eyes, the very tools you need to navigate the void, are being systematically deformed by the absence of the Earth's pull. While your vision blurs, your skeletal system begins a much more permanent retreat. On Earth, your bones are not static pillars, they are a dynamic mineral bank. Your body is constantly depositing calcium to keep them strong and withdrawing it when it needs it elsewhere. But in the deep dark, your skeleton receives a terminal message: you are no longer necessary. Because you are weightless, your body realizes that your bones are overbuilt for the environment. In a desperate act of biological recycling, your body begins to dissolve its own frame. Every month you spend in the void, you lose roughly 1 to 1.5% of your bone mineral density. In a single decade of interstellar travel, you would lose more bone mass than an elderly person on Earth loses in 20 years of osteoporosis. This leads to the skeletal wash, the most visceral evidence of our biological fragility. The calcium being stripped from your bones has nowhere to go but into your bloodstream. Your kidneys, already struggling with the fluid shift, are suddenly overwhelmed by a massive influx of minerals. This leads to a near-constant risk of agonizing kidney stones, but the deeper horror is where the bone actually ends up. As your body filters this excess calcium, it is eventually excreted through your urine. In a very literal sense, the skeleton you are losing is leaving your body through the ship's recycling system. You aren't just living in space, you are losing the physical materials that make you a creature of Earth. Within a few years, your bones could become so porous that they resemble glass. You are becoming a ghost in a machine, a fragile shadow of the human who once stood on the launch pad. The biological siege is compounded by the information decay of the human cell. We have talked about radiation as a physical threat to the ship, but here we must look at the biological receipt. Even with the best shielding humanity can conceive, galactic cosmic rays, those heavy ionized nuclei moving at near light speeds, will eventually find their way into your marrow. When one of these particles strikes a human cell, it doesn't just cause a spark, it shatters the double helix of your DNA. Your body has evolved mechanisms to repair this damage, but those mechanisms were built for the low-level background radiation of Earth. In the deep dark, the hits come too fast and too hard. Your DNA becomes a mosaic of errors, a corrupted file that may cause long-term neurological damage or systemic failure. Your immune system, already weakened by the stress of isolation, begins to fail. Viruses that your body has kept dormant for decades, like Epstein-Barr or shingles, can reactivate, turning your own body into a reservoir of disease while you are light years from a hospital. This creates the ultimate evolutionary trap. We imagine ourselves as interplanetary travelers, moving back and forth between the stars and the Earth. But biology is a one-way door. After decades of living in the weightless, irradiated void, your body has rebaselined itself for the between. Your heart is too weak to pump blood against 1G, your bones are too fragile to support your frame, and your nervous system has adapted to the clinical stillness of the ship. If you were to attempt to return to Earth after 40 years, the very act of landing would be a physical assault. The sudden return of Earth's gravity would feel like a crushing weight on your chest, potentially making simply standing an enormous physiological challenge. You have survived the journey, but you have lost the physical right to walk on the world that birthed you. You have become a biological exile. But the most unsettling question of the biological barrier is the question of the unborn. If a single human life is dismantled by the void in decades, what happens to a civilization that attempts to stay for lifetimes? We have almost zero data on how a human fetus develops without the signal of gravity. A fetus develops in response to the stresses of its environment. If that environment is missing the constant, heavy pull of Earth, will the child's heart ever grow strong enough? Will their spine ever curve correctly? We are talking about the possibility of biological speciation, the accidental creation of a new branch of humanity that is physically and genetically incompatible with the rest of our family. We didn't go to the stars to expand humanity, we went there to watch it divide. We are trying to preserve the species, but we are actually engineering its transformation into something we can no longer recognize. The biological barrier reveals the final irony of our ambition. We have spent billions of dollars trying to solve the problems of engines and fuel. We have built ships that can bend space and reactors that can power cities. But we have forgotten that the most complex and fragile machine on the ship is the one we didn't build, ourselves. The human body is not a universal constant, it is a planetary response. It is a piece of the Earth that has been temporarily granted consciousness. When we try to remove it from the Earth begins to pull its atoms back. We aren't conquering the universe is digesting us, one bone and one cell at a time. The hero of the starship is a myth. The reality is a frail, elongated survivor who has traded their heritage for a heartbeat. We have survived the distance, the speed, the radiation, and the time. But now we have hit the wall of our own skin. We have realized that the machine is stronger than the pilot, and this leads us to the next, most logical link in the chain. If the human body is too fragile for the journey, if we are being dismantled by the very vacuum we are trying to cross, then the mission must rely on something more durable. It must rely on a system that can sustain itself without the presence of a planet. But as we are about to discover, the ship itself has an expiration date. In the next section, we are going to look at the self-sustaining barrier. We will explore why a starship is not a vehicle at all, but a fragile island of order drifting through an ocean of entropy. Are you ready to see why the greatest threat to a 100-year voyage isn't a lack of fuel? It's the fact that in a closed loop, both machines and civilizations eventually lose the will to function. On Earth, we are the beneficiaries of a planetary grace that we have never had to earn. We live with the subconscious assumption that the world around us is an infinite, self-healing engine of abundance. If a building crumbles, we have the raw materials of a crust to rebuild it. If a crop fails, we have a global trade network to replace it. We have never had to live in a world where every single atom must be accounted for, and where the loss of a single specialized skill is a sentence of extinction for the entire species. But as we transition from the fragility of the human body to the cold logic of the machine, we hit a wall that no amount of engineering has ever breached. This is the self-sustaining barrier. We are about to discover why a starship is not a vehicle at all. but a fragile island of order drifting through an ocean of entropy. We will see why the greatest threat to a 100-year voyage isn't a lack of fuel, but the terrifying reality that in total isolation, both machines and civilizations eventually lose the will to function. To understand the horror of the machine, we must first look at the parasitic outpost. On Earth, we celebrate the International Space Station as a triumph of human persistence. It has hosted human beings continuously for decades, and we use it as a blueprint for our future among the stars. But the station is not a starship. It is a parasite. It is tethered to Earth by a continuous, invisible umbilical cord of resupply. Every few months, a vessel arrives carrying fresh water, new oxygen canisters, spare computer chips, and specialized tools. Behind the crew stands a literal army of thousands of engineers on the ground, monitoring every breath of the station in real time. If a pump fails, Earth builds a new one. If a software bug appears, Earth sends a patch. Without this constant dialogue with the mother world, the International Space Station would become a silent, airless tomb within months. An interstellar mission has no mother. The moment the engines fire, the umbilical cord is not just stretched, it is severed forever. You are no longer an explorer, you are a resident of a high-tech CPR machine, and every year the rhythm becomes harder to maintain. This leads to the first what moment of the self-sustaining barrier, the realization that total closure is a physical impossibility for our current level of civilization. Every space mission in our history has depended on an open-loop system. We take what we need from Earth and discard what we don't. But on a century-long journey, every critical resource you carry at launch is the total inventory for the duration of the mission. You must achieve what no civilization in history has demonstrated: a perfect 100% closed loop. In the late 1980s, humanity attempted to model this kind of closure with Biosphere 2, a 3-acre sealed ecosystem in Arizona. But within 2 years, its oxygen levels had fallen dramatically, its ecology had become unstable, and the experiment had exposed a humbling truth. We can build machines that scrub air and filter water, but we cannot replicate the billions of years of evolutionary tuning that keep a planet in equilibrium. A starship's life support system is not a garden. It is a clinical resuscitation of a dying world, and every year the rhythm becomes harder to maintain. Even if the ecosystem remains stable, the mechanical entropy of the ship will eventually claim the mission. On Earth, we believe that strong means permanent, but in the reality of the deep dark, time is a solvent. Every moving part has a finite operational life. Bearings wear out, seals age, and electronic components suffer from electromigration, where the very electricity flowing through a chip physically pushes atoms out of place, creating microscopic voids and short circuits. This is the tire of the atom. Over a 100-year voyage, your ship will experience millions of thermal cycles, creating material fatigue that grows with every light year. The terrifying reality is not that a single processor might fail, but that the ship's very capability to replace it might go extinct. To keep a starship functional for a century, you don't just need spare parts. You need an entire industrial civilization capable of manufacturing them from scratch. You are in a race against the slow, quiet disintegration of your own world, and the universe is methodically dismantling the finish line. But as the metal tires, a much more profound decay begins to take hold inside the mind of the colony, the knowledge divorce. A starship is not just a collection of wires, it is a collection of ideas. The systems that keep you alive, the reactors, the scrubbers, the navigation computers, are the products of thousands of years of accumulated human expertise. But knowledge is a living thing. It requires a culture to survive. History shows us that specialized knowledge can vanish in a single generation if the social structures supporting it are disrupted. After the fall of the Western Roman Empire, the sophisticated techniques behind large-scale infrastructure were no longer widely practiced. The aqueducts were still standing, but the specific engineering knowledge required to fix them had drifted away. They had lost the language of their own technology. Imagine a generation ship in year 80 of its journey. The people currently in charge were born in the void. They have never seen an ocean or a factory. They have learned their engineering from manuals written by ancestors who have been dead for decades. If a master engineer dies before their apprentice is fully trained, a tiny sliver of the ship's survival is lost. Over a century, these microlosses accumulate into a dark age of engineering. The crew might still know how to operate the ship, but they may no longer understand the fundamental physics required to innovate when an unexpected failure occurs. They become ritual technicians, performing the motions of maintenance without the depth of understanding. They are the residents of a high-tech haunted house, surrounded by machinery they can no longer truly control, praying that the machine mother doesn't stop breathing. The psychological toll of this isolation leads to the stagnation paradox. On Earth, we are part of a global conversation, constantly renewed by new ideas and unpredictable challenges. But on a starship, the library is finite. The conversations have all been had. When every resource is rationed and every role is predetermined by the ship's survival needs, the drive for creativity dies. Why invent a better pump when the current one is all you have the parts for? You are building a society where stability is the only virtue, and where any change is a threat to the equilibrium. You have reached for the stars, but you have done so by turning humanity into a maintenance unit for a machine that has forgotten why it left home. The greatest distance on an interstellar voyage isn't the light years between suns, it is the gap between the people who launched the ship and the people who must finish the journey. This leads to the final, most haunting irony of the self-sustaining barrier, the arrival. We imagine that once the ship reaches another star, the struggle ends. But if you arrive at a world like Proxima b, a scorched, tidally locked rock, you are faced with an impossible choice. You cannot land because your body has been dismantled by the journey, as we saw in the previous sections. You cannot return because your fuel is gone. Your only option is to continue living in the machine, but the machine is now a century old. Its electronics are degrading, and the deep knowledge of its construction is a fading memory. The self-sustaining machine was never meant to be a permanent home. It was meant to be a bridge. And when the bridge doesn't lead to a shore, it becomes a cage. The self-sustaining barrier has won, not by a sudden explosion, but by the slow, relentless pressure of entropy. You have built a ship that can survive the radiation and the vacuum, but you have found that you cannot build a civilization that can survive time. You have traded the messy, dangerous, but self-healing world of Earth for a sterile, perfect, but terminal island. We are the first generation to realize that the most dangerous thing about interstellar travel isn't the distance. It's the fact that the universe does not provide a safe point. Once you leave the cradle, you are in a race against the decay of your own technology and the narrowing of your own mind. But even as we huddle in our aging tunnels, watching the machines tire and the memories fade, we are still facing the final absolute ceiling of our reality. We think that if we can just solve the maintenance, if we can just perfect the closed loop, we will eventually claim the galaxy. But the stars themselves have set a limit that no amount of endurance can bypass. A limit that ensures that no matter how fast we go or how long we last, the universe will always be bigger than our reach. In the next section, we are going to look at the physics barrier. We will explore the speed of light wall and the horizon of causality, and why the universe itself may be structured to ensure that no two civilizations can ever truly share a single now. Are you ready to see why the final wall isn't an engineering problem, but a law of nature? We have spent this entire journey focused on the struggle to move. We have treated the light years as a distance to be conquered, and the speed of light as a record to be broken. We imagine that the moment of triumph occurs when the engines finally push us to relativistic speeds, or when the warp bubble first stabilizes around the hull. In our cinematic dreams, the arrival is a moment of silence and beauty, the starship gently gliding into the orbit of a new world, while the pioneers look out at an emerald horizon. But as we transition from the mechanics of the journey to the reality of the destination, we hit a wall that is more violent than the vacuum and more precise than the math of the engine. This is the arrival barrier. We are about to discover why in the deep dark, getting there is only half the problem, and why the act of stopping might be the most destructive thing a civilization can ever do. To understand the horror of the arrival, you must first look at the kinetic verdict. On Earth, we are used to the idea that stopping is a secondary concern. You take your foot off the gas, you apply the brakes, you let the air and the friction of the road do the work for you. But in the interstellar void, there is no road, there is no air, there is no resistance. Every joule of energy you spent to accelerate your ship to 10% of the speed of light is energy that you still possess. It is carried by your mass. To arrive at a star, you don't just need to reach it. You have to reverse everything you have done. You have to fire your engines in the direction of travel, fighting against your own momentum for years. This is the first what moment of the arrival. The energy debt of an interstellar mission isn't just large, it is doubled. The rocket equation, which was already our enemy during the launch, now applies its exponential cruelty to the finish line. You must carry the fuel to move your fuel, and then you must carry the fuel to stop that fuel. This leads to the search for the needle. We often think of stars as massive, unmoving landmarks, lighthouses that stay exactly where the maps say they are. But as we explored in earlier sections, the galaxy is a violent choreography of motion. Proxima Centauri is moving through the darkness at roughly 14 kilometers per second. Our own sun is hurtling in a different direction. When you aim a starship at another sun, you aren't aiming at where it is now. You are aiming at where it will be decades into the future. Imagine trying to hit a single grain of sand with a needle from 1,000 miles away, while both you and the sand are caught in a different hurricane. If your navigation is off by even 1,000th of a degree, a deviation so small it is invisible to the human eye, by the time you cross the light years, you will miss the entire star system by billions of miles. You arrive at the coordinates, but the sun is not there. You are a ghost passing through an empty room, unable to turn back and unable to slow down. But let's assume your math is perfect. Let's assume you have found the star. Now you must face the causal horizon. If your ship is using a superluminal warp drive, moving faster than light, you are effectively blind to the road ahead. Because you are outrunning your own signals, information from the star system cannot reach the front of your bubble. You cannot see a rogue planet in your path. You cannot detect a sudden solar flare from the target star. You are like a man running through a dark forest with his eyes closed, trusting that the path you memorized a century ago hasn't changed. If an obstacle has moved into your trajectory, you won't know until the moment of impact. The faster you travel to save time, the more disconnected you become from the reality of your destination. You aren't navigating, you are gambling with the survival of your species on a map that is already out of date. The most terrifying dimension of the arrival, however, is the snowplow effect. Throughout the journey, as your ship has been screaming through the interstellar medium, your bubble or your magnetic shields have been sweeping up trillions of hydrogen atoms and microscopic grains of dust. As we saw in Section 4, these particles don't just disappear. In many theoretical models, they become trapped at the leading edge of the ship's geometry. You are building a causal dam, an accumulation of high-energy matter that you are carrying forward at relativistic speeds. And here is the realization that turns the Pioneer into a monster. The moment you finally decelerate, that dam breaks. All of the energy and matter you collected across 4 light years is released at once in a focused, lethal beam of radiation aimed directly at the system you just reached. This is the radiation execution. You arrive at Proxima Centauri not with a message of peace, but with an astronomical weapon. The pulse of gamma rays and high-energy particles released by your arrival could be intense enough to incinerate the atmosphere of the very planet you intended to settle. You spend a century surviving the dark, only to realize that your first act upon arrival is the sterilization of your new home. The universe has set a safety lock on the stars. It tells us that if we try to cross the distance too quickly, we arrive as a catastrophe. We are forced to choose between a slow journey that destroys the crew or a fast journey that destroys the destination. The psychological toll of this choice creates a state of arrival dread. Imagine being a third-generation crew member. You have spent your entire life in the artificial cradle, maintaining the machines and studying the history of an Earth you never knew. You have reached the target. You can see the red sun through the viewport, but you know that the leading edge of your ship is a loaded gun. You know that you cannot land without firing. This is where the heroism of the mission evaporates. You realize that you aren't an explorer. You are a biological anomaly in a weaponized vessel. The golden shore you were promised is a mirage that is physically protected by the very laws of physics that brought you there. You have reached the stars, but you have found that the door is only open if you are willing to burn the house down. This leads us to the no-rescue reality. On Earth, every arrival is supported by infrastructure. When a ship enters a harbor, there are tugboats, docks, and supplies. But at the end of a 1 light-year journey, there is nothing. You arrive in a system where the environment is actively trying to kill you. You have no resupply missions coming from home. You have no hospital to refer to when the skeletal wash of Section 8 becomes terminal. You are a small, fragile group of humans in a century-old machine, standing on the threshold of a world that is fundamentally indifferent to your presence. The arrival barrier is the realization that the destination is not a sanctuary, it is just a different kind of void. You have traded the empty dark of the journey for the radioactive dark of the red sun. The arrival barrier has won, not by breaking your engines, but by revealing the futility of the target. You have survived the distance, the speed, and the time, but you have found that you cannot arrive without becoming a weapon, and you cannot land without becoming a corpse. We are the first generation to acknowledge that the stars are not a new world, they are a verdict. They are a reminder that some gaps are not meant to be bridged. We have built a ship that can bend the universe, only to find that the universe has placed a censorship on our arrival. But as we huddle in our orbit, watching the red flares of an angry sun, and realizing that we can never truly step off the ship, a final and much more haunting question begins to form. If we cannot land, if the arrival is a catastrophe and the destination is a graveyard, then what happens if we try to go back? We look at the tiny blue spark of Earth in our monitors, and we realize that the return is even more impossible than the arrival. In the next section, we are going to look at the return barrier. We will explore why coming home is a mathematical and emotional fiction, and why the first person to reach the stars is destined to be the last human who will ever know where they came from. Are you ready to see why in the deep dark, there is no such thing as a round trip? We have spent our entire lives believing in the absolute promise of the return. On Earth, we are defined by the round trip. We go to work so we can return home. We cross oceans so we can share the stories of our travels. We launch ourselves into the sky with the unwavering certainty that the same engines that took us up will eventually bring us back down. This cycle of departure and return is the fundamental rhythm of the human spirit. It is the safety net that allows us to be brave. We imagine the first interstellar travelers as modern-day Odysseus's, facing the sirens and the storms of the void, only to one day see the familiar blue horizon of Earth rising in their viewports. But as we move from the catastrophic arrival to the reality of the journey back, we hit a wall that is more permanent than distance and more cruel than physics. This is the return barrier. We are about to discover why coming home is a mathematical and emotional fiction, and why the first person to reach the stars is destined to be a ghost from a past that no longer exists. To understand the horror of the return, you must first look at the fuel bankruptcy. We have already explored the staggering energy debt required to reach even 10% of the speed of light. We saw how the rocket equation demands an exponential increase in mass for every kilometer of velocity. But there is a detail in those equations that mission brochures often gloss over. There are no gas stations in the interstellar medium. To return home, you must carry the energy for 4 independent legs of the journey: the initial acceleration from Earth, the deceleration at your destination, the reacceleration back toward the Sun, and the final stop upon arrival. This is the first what moment of the return. Because of the rocket equation's tyranny, carrying the fuel for a return trip doesn't just double the ship's mass, it squares it. If you need 1,000 tons of fuel to get to Proxima Centauri, you might need 1,000,000 tons to get back. You are forced to build a ship the size of a city just to move a capsule the size of a car. Most realistic mission profiles for interstellar travel are, by necessity, one way. They are sentences of permanent exile, signed the moment the engines first ignite. To go to the stars is to say goodbye to the Earth, not for a decade, but for eternity. But let's assume you solved the fuel problem. Let's assume you built a ship that could reignite its engines after a century of dormant coasting. Now, you must face the retrospective execution of time dilation. In Section 5, we looked at the horror of outliving your family, but the return journey turns that horror into a civilizational erasing. If you travel to a star 40 light-years away at 99% of light speed, you might age only a few subjective years. But for the Earth you left behind, 80 years have screamed past. When you finally re-enter the solar system, you aren't a returning hero. You are an archaeological anomaly. You are a biological relic of the 21st century, stepping into a 29th century world. Psychological toll of this homecoming is a trauma for which there is no terrestrial name. You step out of the airlock expecting to see a world that remembers your sacrifice, but the people who launched you are dust. The space agency that funded you is a historical footnote. The very language you speak has drifted into a dead tongue, and the culture you represent has been superseded by a millennium of evolution. You are a mind from the past, trying to inhabit a future that has no room for your memories. You haven't returned to home. You have arrived at a destination that is just as alien as the red sun you fled. You realize with a crushing weight that the Earth you loved didn't wait for you. It died centuries ago. This leads to the biological mismatch of the return. As we explored in Section 8, your body has been optimized by the journey. Your heart is too weak for planetary gravity, your bones are as brittle as glass, and your immune system is a biological archive of extinct diseases. If you were to attempt to land on Earth to feel the soil beneath your feet, the return of 1G would be a physical assault. Your internal organs, used to the weightless between, would be crushed by the vertical pull of your home world. You have survived the stars, but you have lost the physical right to inhabit the Earth. You are forced to live the rest of your life in a pressurized glass cage in orbit, staring down at a blue marble that would kill you if you tried to touch it. You are home, but you are still a prisoner of the vacuum. But there is a final, most unsettling irony buried in the return barrier, the obsolescence loop. Think about the speed of human progress. If you launch a ship today that takes a century to reach the nearest star, it is statistically certain that halfway through your journey, Earth will develop a better engine. A ship launched 50 years after yours could be twice as fast, overtaking you in the dark and arriving at the destination decades before you do. You spend your life in a metal tube, sacrificing your heart and your timeline, only to arrive and find a welcoming committee that arrived 50 years ago. They look at your ship as a primitive curiosity, a wooden canoe in a world of supersonic jets. You have reached the stars, only to find that your entire sacrifice was made redundant by the very progress you were trying to advance. This creates the peak of civilizational isolation, the realization that humanity is not a single, connected species. By entering the relativistic trap, you have moved out of the human timeline. You have become a separate branch of evolution, a time refugee who is perpetually out of sync with the collective. The return journey is not a reunion, it is a haunting. You are a ghost from a previous era, arriving in a world that has already solved the problems you were sent to investigate. You realize that the barrier we can't escape is not the light speed or the radiation. It is the fact that time is a one-way door. The universe allows you to leave, but it ensures that the person who comes back will never be the person who departed. Elias Thorne, the archetype we have followed, is the physical embodiment of this verdict. He returned to warn us, but he found that he couldn't even deliver a greeting. He realized that home is not a place you can point to on a map. It is a biological and social equilibrium that exists only in a specific moment of time, and that moment is gone. He sat in his lunar enclosure, watching the Earth, realizing that the greatest distance in the universe is not the space between stars. It is the silence between the man who went and the species that stayed. He was the first human to touch another star, and he was the last human who will ever know where he came from. The return barrier has won, not by stopping your engines, but by making your homecoming a tragedy. You have built a ship that can bend the universe, only to find that you cannot bend the clock. You have survived the energy debt and the materials grave, but you have lost the battle for belonging. We are the first generation to acknowledge that the stars are not an invitation to expand. They are a wall that forces us to realize what we have right here. We have spent trillions of dollars to stand on a ghost world, only to find that we turned our own world into a ghost in the process. But as the airlock closes and the silence of the Pioneer becomes absolute, as the last message from Voyager 1 eventually fades into the static of the Big Bang, one final realization remains. We have looked at why we can't go. We have looked at why we can't stay. And we have seen why we can never truly come back. In our final section, we are going to look at the final verdict. We will explore the philosophy of the speck and the true reason why humanity's future is not in the stars, but with the Earth. We will discover that the greatest victory of our species was not building the starship, but understanding why the backyard was enough. Are you ready for the final, heartbreaking realization of the human odyssey? The ladder is finished. Now we must look down. We have reached the end of the chain. For over 2 hours, we have followed the arc of a species that dared to challenge the geometry of the universe, and we have witnessed the staggering price humanity has paid for its curiosity. We have seen the digital brains of our ships succumb to dementia, the hulls of our vessels turn into material graves, and the very stars themselves warp into strangers that no longer recognize us. We have dismantled the dream of the interstellar age, piece by piece, only to find a new kind of hope in the ruins of our ambition. But as the long journey of our exploration comes to a close, as we face the absolute finality of the barriers we cannot escape, we must confront a truth that is far more unsettling than any engineering failure or relativistic trap. It is a truth that doesn't live in the circuits of a computer or the equations of a physicist, but in the final, cold silence of the messengers we have already sent. This is the final verdict. To understand the weight of the end, we must first look at the heartbeat of Voyager 1. Launched in 1977, this car-sized probe has been our singular representative in the interstellar dark for nearly half a century. It is currently drifting more than 24 billion kilometers from home, moving through a vacuum so thorough that the probe is the only solid object for billions of miles. But Voyager's heart, a lump of decaying plutonium, is dying. Every year its power output drops. One by one, the heaters are turned off. One by one, the scientific instruments go dark. We are watching the slow-motion coma of our greatest pioneer. Within the next few years, the signal will likely vanish entirely. Voyager 1 will not stop moving. It will continue to scream into the dark at 17 kilometers per second for millions of years. But it will be silent. The umbilical cord of radio contact, which we have held onto like a religious lifeline, will finally snap. Voyager will become what it was always destined to be. A message in a bottle thrown into an ocean by a civilization that knew its own island was eventually going to sink. On the side of Voyager sits the golden record, a copper disc containing the sounds of rain, the laughter of children, and the music of our greatest composers. We sent it as an invitation, a hello to the neighbors we hoped to find. But as we have explored through the physics of isolation, we now know that no one is coming to find the bottle. The distances are too vast, and the causal horizons are too tight. The golden record is no longer an invitation, it is an epitaph. It is a recording of a species that once believed the universe was a neighborhood. It is the evidence of a brief, flickering moment in history when we were still human enough to feel wonder and still primitive enough to feel hope. Voyager is not a bridge to the future. It is a time capsule of a past that we are already leaving behind. Why did the universe build these walls? Why the fuel debt? Why the radiation siege? Why the time dilation? As we stand at the end of the ladder, the answer reveals itself not as cruelty, but as sanctuary. The barriers are the universe's way of ensuring that life remains a local event. Nature has partitioned the cosmos into sovereign cells, allowing each world to develop its own history, its own beauty, and its own end, without interference from the chaos of the rest. The distance between stars is the garden wall that protected Earth for 4 billion years. If the wall were easy to climb, we might have been destroyed by the radiation of a neighbor sun long before we ever learned to speak. Our isolation is the only reason we were ever allowed to be free. The prison we have described for 2 hours is actually the fortress that kept us alive. We have spent trillions of dollars and centuries of potential trying to leave the Earth. We have dreamed of warp drives and generation ships, believing that the next world would be better than the one we have. But the legacy of the dream is the realization that Plan A was the only plan that ever mattered. We are a biological fluke, a planetary miracle that occurred in a very specific gravity, under a very specific light. The lesson of the chain is one of profound humility. It tells us that we are not the masters of the cosmos, we are its observers. Our curiosity is a flame that is meant to illuminate our own home, not to set the neighbor's house on fire. The starship was never a vehicle of transport. It was a mirror that showed us the staggering, impossible value of the pale blue dot. As the sun sets on this exploration, I want you to look at the night sky one last time. But this time, don't look at the stars as targets. Don't look at them as real estate or second chances. Look at them as the boundaries of our sanctuary. They are the beautiful, cold fires that define our place in the infinity. The story of humanity is not a story of a species that conquered the galaxy. It is the story of a species that wandered to the edge of the driveway, saw the depth of the ocean, and had the clarity to realize that the shore was beautiful enough. We are the infants in the dark, reaching for the lights in the ceiling, never realizing that the room we are in is the only one that will ever truly love us. The barrier we can't escape has won, not by breaking our spirit, but by defining our purpose. We have survived the climb, but we have reached a peak where we can finally see the truth. The stars are waiting, but the Earth is breathing. We are home. And as the last radio signal from Voyager 1 eventually fades into the background noise of the universe, as our most distant messenger finally goes quiet in the dark, we can look up at the night sky and know the final verdict. We were never meant to reach the stars because we were meant to be the ones who saw them. And in a universe of infinite scale and absolute isolation, being the only ones who can see the light is the greatest triumph of all. The airlock is closed, the engines are silent, the Pioneer is at rest, the ladder is finished, and as we look down from the height of our ambition, we see the Earth for what it really is. A tiny, fragile spark in a black ocean, a noisy room in a silent house, and the only place in the entire universe where you will ever truly find your way back. Thank you for joining me on this journey through the heart of our isolation. If this exploration of the limits of our species has changed the way you look at the stars, please take a moment to like the video and subscribe to the channel. Your support allows us to continue building these cinematic bridges into the unknown. Keep looking up, but never forget to look back. Good night.